Okay, Algebra 1 fans, our topic for today, this is Notes 5-4, solve compound inequalities. Compound is when we use the word or and, when we have more than one inequality. Our objectives after this lesson, students should be able to solve compound inequalities containing the words and or, and graph their solution set. So before we begin, let me give you your joke of the day. What do you call a lazy kangaroo? The answer is a pouch potato. Couch potato? Pouch potato? All right, well, let's see. This is actually kind of a short set of notes. It's only the front page that we have to do. So compound inequalities. Again, compound means we are combining. It's more than one. So solve the following inequalities and graph their solution sets. So number 1, x plus 5 is less than 9 and x minus 4 is greater than negative 6. So we're using the word and to combine these. We have two separate inequalities. So what we'll do is we will solve two inequalities. We'll solve these separately. Here we would go minus 5 and we would get x less than 4. And over here, we would move negative 4 by adding it, and we would get x greater than negative 2. So x is less than 4 and x is greater than negative 2. Now, I'm gonna write some stuff here in a moment, but for now, let's look at graphing this. Here's positive 4, here's negative 2. Now, less than 4, if I graph these separately, less than 4 goes to the left. Greater than negative 2 goes to the right. But if we're using the word and, we are only looking at where they intersect, what they have in common. And in this case, notice that both of the lines are between negative 2 and positive 4. That's where they overlap there. So, our solution set is between negative 2 and positive 4. So, I can write my solution set like this if I want, but we actually have a quicker way of writing it. Remember, we could write this as negative 2 less than x less than 4. X is between these two values. So we could say the set of x's such that negative 2 is less than x is less than 4. If you write it with the word and, it is still good. It's fine. But we have x is less than 4. Well, there's that right there. I have it written. X is greater than negative 2 is the same as negative 2 is less than x. So I could write it this way. And there's our solution. Number 2, the word or. Now, or is usually going in opposite directions, like that, and is usually going between what they have in common. In this case, let's go minus 5. So x is less than negative 8. Now, we subtracted 5. We do not change the symbol. We don't switch it, only when we multiply or divide by a negative. Or, here we would add 4 to both sides. We would get x is greater than 5. Now in this case, there's no short way to write it. So we say the set of x's such that x is less than negative 8 or x is greater than 5. That's our solution set. On a number line, negative 8, positive 5. X is less than negative 8 is open and goes to the left. Less than. X is greater than 5 is open and goes to the right. I'll put arrows on my line here. So basically what you're doing in a compound inequality is you're solving two of them and then you're graphing both of your inequalities. So it's not more complicated than what we were doing in the last couple of lessons. We're still solving inequalities. It just means that you have a little bit more work to do. Now, number 3, notice this is written the way that we wrote our answer to number 1. This is a compound inequality. It is an and problem. If we wanted to split this into two inequalities like here, we could write it with the word and, but it's actually nice the way this is written because we can solve it at once. The goal is to get the variable by itself. Now the number that is with the m is plus 6. It's a constant. Well, to move a constant, a positive constant, we subtract. And normally we would say you subtract left side, right side. But here we have a left, a right, and we have a middle. So what we'll do is we'll subtract 6 on the left side, we'll subtract 6 on the right side, and we'll subtract 6 in the middle. So for each section, we do the same thing. -8 minus 6 is -14, less than or equal to. Here, 6 minus 6 is 0, so we have just m, less than 13 minus 6, which is 7. And there we go, there's our answer. The set of m's such that -14 is less than or equal to m is less than 7. So on a number line, here's 0, here's -14, here's positive 7. Notice that the variable is between the two values, so we will graph between. Less than or equal to, the -14 is closed. Less than 7 is open. And where do we graph? We graph between. So all the values between -14, including -14, would make this true. Let's take number 4. 2a plus 9 is less than -3, or 4a minus 10 is greater than or equal to 18. So this is an or problem. So we'll solve these separately. So we'll go -9. And then we'll divide by 2. A is less than -6, or here we would go plus 10. So 4a is greater than or equal to 28. Divide by 4. And we get a is greater than or equal to 7. So it's the set of a's such that a is less than -6 or a is greater than or equal to 7. So we'll plot -6, we'll plot positive 7. Now, -6, that's open. Less than goes to the left. A is greater than or equal to positive 7, that is closed, because 7 is part of the solution, and we graph that to the right. And that's it. All right, we'll do 2 more here. Go ahead and try these on your own. Number 5 is an and problem. The x is between, so I'll solve this all at once. Let's move the constant first. Now the constant is in the middle section, because that's where x is, that's plus 5. So we'll go minus minus. 5 minus 5 is 0. Now, in this case, if there's nothing else on that side, I am going to write the number 0. I cannot leave it blank. So we'll have 0 less than or equal to, that's x over 3. And that's less than 6 minus 5 is 1. Now how do we undo division? We multiply by 3. So we have to multiply each part of this by 3. Now 3 times 0 is still 0. Less than or equal to. Here 3 divided by 3 is 1, so we get x. Less than 1 times 3 is 3. So there's the solution set. To graph that, here's a number line, and we have 0, and we have 3. Now 0 less than or equal to x is closed. X is less than 3 is open. Where's the variable? It's between. So we can just shade it between, or I just draw the lines like that. If you doubt that that's correct, pick a number between 0 and 3 and you could substitute it. If I took the number 2, for example, and I had, so 5 is less than or equal to 2/3 plus 5. That's 5 and 2/3 less than 6. Hey, that is between positive 5 and positive 6. So this is good. Last one. Number 6 is an OR problem. First thing we'll do is distribute here. So 3x plus 6 less than or equal to 6. Move the constant by subtracting. Divide by 3. Now 0 divided by anything is 0. Or we'll go minus 4. We'll move the constant. Now that leaves, be careful, that's negative 3x less than or equal to negative 15. To undo multiplication, we will divide by negative 3, but when you divide by a negative, you get 1x, or I'll write it down here. We get 1x, but when I divide by a negative, I have to switch the symbol greater than or equal to positive 5. So we have 0, we have 5, x is less than or equal to 0, that goes to the left. X is greater than or equal to 5, that goes to the right. So anything left of 0, including 0, anything right of 5, including 5, has to make this true. Last thing I'll do, I'll pick a value to check. Let's pick 6. Let's try 6. So if I substitute a 6 here, I would have 3 times 6 plus 2. Now that's 8. 3 times 8 is 24. 24 is less than or equal to 6? No, it's not. That's false. Uh-oh. Now here, 4 minus 3 times 6, 4 minus 18 is negative 14. Is that less than or equal to negative 11? That is true. When you have an OR problem, you don't need both of these to be true. You only need one of them. So it's either this or this. And because this one is true, we can say that the overall inequality is true, so we are good. This is the solution. And that is the end of the notes.